Okay, now this slide we discuss about how the stationary phase features can affect your separation in gas chromatography. So in this first slide, it is a effect of stationary phase type. Okay, this has been discussed in previous video. Okay, between non-polar and polar, and this is the extended example prepared by a column brand by the name of Restec. Okay, so the above chromatogram here is dimethyl polysiloxane. Okay, this is 100% methyl, means it's really hydrophobic. And the second one is relatively polar, whereby it contains a little bit of polyethylene glycol base wax. Okay, you see the set of the analytes are hydrocarbons. Okay, so if it's separated in a non-polar column, okay, it will be separated accordingly lah. 1, 2, 3, 4 means that the higher the molecular weight, therefore the higher the boiling point, right? So therefore the higher the boiling point and molecular weight will be eluted out the last. But why, when we use polar column, the third and fourth analyte eluted first? Okay, any idea? It must be something to do with the structure as well as polarity. So throw your answer inside the WhatsApp chat. Okay, the second one is we go into how column length will affect your separation. Greater length, okay, give resolution, of course, because it gives you the separation space for the analyte to resolve themselves. However, you will jeopardize the retention time and it can prone to peak broadening. So we already discussed about the effect of efficiency as compared to length, and the longer it is, your HETP or H will be higher. We don't want high H, we want low H as stated in Van Dampier equation. Okay, so greater length up to 60 meter. Okay, yes, of course, this one is not we are not satisfied with this peak, so we have to increase the column length in order to resolve these two. Okay, so you have to increase 4 times as compared to the first one in order to resolve this. However, you are affecting the total separation time up to 15 minutes. Instead of only 3.7, you get 15.3. So this is around 12 minutes extra. Okay, as I said before, time is always money, right? If you are in the position of doing analysis and you get this kind of analysis or separation, will you stick with 60 meter or you think about something else? Okay, throw your answer inside the WhatsApp chat. What can you do to increase the resolution without doing this, without increasing the column length? First is because time, second is because it's expensive. Okay, throw your answer. Okay, next is effect of the column internal diameter. Okay, so what is the internal diameter usually used in P chord and W chord? So it's around 50 micron up to 75 micron, right? Or up to 100 micron lah. Okay, so narrow column increase resolution. How? Okay, so as compared to 0.1 and 0.25 over here, the resolution is up to 4. Between these two is 4. Well, this one is 1.63. Both are okay. Okay, both are okay because both are more than 1.5. But lower column, low ID will reduce sample loadability. Means that you will get lower signal. When you get lower signal, means that when you want to do calibration curve, it's not going to give you higher linearity. Okay, so that what you mean. That what you want is that a high peak signal. So next is the effect of coating thickness in W chord. In W chord. because only in wall coated open tubular yang ada coating, right? So the greater the film thickness, okay, means that more polymer liquid phase now, it will increase the resolution. Why? And increase loadability. Why? Okay. So when we increase the film thickness from 0.25 up to 1, 4 times over here, okay, the resolution of these two increase up to here. Okay, why? Because when you have greater thickness, okay, open tubular, so W chord, so this is the column, okay, of course you can increase loadability. Means that the analyte will go inside, absorb more, absorb, but when it want to go out, it need time. That's why it prolong retention time. But because it can absorb more on the coating, the analyte have time to resolve themselves. Means that analyte first masuk, okay, analyte second pun masuk, and then analyte first keluar pula, and then analyte second keluar next. So it give more space to separate. Okay, and of course increase loadability lah, more can go in. But when you prolong the retention time, you also reduce the it reduces the efficiency as well. As you can see here, this is sharp, this is wide or broad. Okay. In this case, do we want to stick with 0.5 micron or 1.0 micron? So give your answer in the WhatsApp chat. Okay, finish on the effect of the stationary phase. We now go to the next part, which is detector. Okay, you already covered several detector in last semester's gas chromatography. Okay, different detector give different type of selectivity, and also not all detector can do all things. Means that you have to understand there are two types of detector. One is very universal, means that it can detect everything. But because it is universal, the sensitivity of course not that good. And then the second type is you have a very specific detector that can detect very sensitive concentration, sensitivity of certain type of analyte, but it is not applicable to another type of sample or analyte. So that's how you understand it. Okay, a non-selective detector means that very universal lah, respond to everything except the carrier gas. So indeed, in comparison with HPLC, a universal detector in GC is same as compared to HPLC UV, because UV detector is very universal in HPLC. A selective detector responds to a range of compounds with common physical or chemical properties. Okay, next slide will show you the different type of them. And specific detector responds to a single chemical compound. Is this usable for us? Depends on your application. If let's say your lab is only doing one compound analysis until the end, then you have the advantage of buying this. Okay. So type of detector, we have a very universal detector. We call it as thermal conductivity detector. How this work is already covered in last semester, but later I will show you video, and also we can do active learning on each of these. The next most universal is flame ionization detector. Basically, GC-FID is like the staple detector in any chemistry lab. Okay, because it can detect all organic compound. Okay, chromatography is mostly for organic compound. Then we have a selective one, electron capture detector for halides, nitrates, peroxides, organometallics. So halides such as all those chloroaniline, nitrates, and peroxides for forensic samples such as the explosive. Okay, and then we have very specific one, only to detect nitrogen and phosphorus. Means that It is usable in agriculture company yang buat baja. Okay, yang buat baja because nitrogen and phosphorus are the two main component used to make fertilizer. Okay, and then we have everything else here lah. Basically, these three is very common. And then another one we have is MS. MS is very universal, but it's expensive. Okay, later you will watch video done by my Master of Forensic student relating to GC with MS, tandem MS. Okay. So this active learning for 20 minutes, we will do information search in the internet. Okay, you have to search on each of the detector mentioned in the previous slide, and you can send photos or information in the WhatsApp chat so that everybody can save and make it as the supplemental notes. I'm not going to go one by one because this already have been covered in your last semester.